Hello everyone. In the previous lesson, we talked about relations and their different types. In this lesson, we will look at functions and their types. So, what is a function? A function is a relation between x and y, but with some special conditions. What are the conditions? All elements of the domain X must have a connection to an element in codomain Y. To understand this condition, we must first understand what is a domain. A function can be seen in this way. It takes an input, processes it, and gives an output. Now, all the possible values that you can provide to a function as the input is called the domain. Consider this example. The possible values that you can give to the function is 1, 2, and 3, which is the set X. Therefore, the domain in this case is X. Now, before I explain to you what is codomain, I'll tell you what is the range of a function. Let's say I gave the input as 1 to the function and I got the output as 2. Then I entered 2, I got the output as 3. Then I input 3 and got the output as 4. So the range of this function will be the set 2, 3, 4, which is the set Y. Here, the codomain and the range mean the same thing. Let's take another example. If Y consisted of 2, 3, 4, 5, and 6, the function f from x to y can be represented like this. Now here, the range of f is 2, 3, 4, but y, which is the codomain, is 2, 3, 4, 5, and 6. Range is a subset of the codomain. So as I said, all the elements of the domain X must have a connection. If there was an element 4 in X, that must also have a connection. All elements in the codomain could or could not have a connection. Like the element 6, it doesn't have a connection. The range in this case will be 2, 3, 4, and 5. The second condition was every element of X can have only a single connection. If 1 is mapped to 2, it cannot be mapped to any other element of the codomain Y at the same time. This case is not possible as 1 is mapped to 2 and 3. Similarly, 3 cannot be mapped to 2 and 4 at the same time. Now, I hope that you have understood what a function is. I said that the function is also a relation. This function can be written as, now this function is also a relation because it is a subset of the Cartesian product of x and y. I said that a relation is a subset of the Cartesian product between the two sets. 1, 2, 2, 3, 3, 4 are present in the Cartesian product. Hence, a function is also a relation. But all relations are not functions. Let's take this as the example. Now, this is a valid relation between x and y, but the element 1 from x is mapped to 1 and 2. This cannot be a function because it does not satisfy the second condition, as well as the first condition, because all the elements of x have not been mapped. Therefore, it can be said that all functions are relations, but all relations are not functions. Now let's talk about the different types of functions. First, the 1, also known as the injective function. In 1, function, every element of y has at most one connection. Let's say 1 is mapped to 2, 2 is mapped to 3, and 3 is mapped to 3 as well. Now this function is not 1, 1 because 3 has two connections. I said that for a function to be 1, 1, every element of the codomain Y can have at most one connection. If instead of this connection 3 was mapped to 4, then this function can be called 1, 1 because every element of Y has at most one connection. If there was another element in Y, 5, still this is a 1, 1 function because 5 has 0 connections, which is less than 1, and every other element has one connection. Now, let's talk about the onto function. For a function to be onto, every element of Y should have a connection. In this example, 5 does not have a connection. Therefore, this function is not onto. If we had this connection, then this function can be called onto. Is this onto? Yes, it is, because every element of Y has at least one connection. Is this function 1, 1? No, it is not, because 4 has two connections. A function which is both 1, 1 and onto is called a bijective function. This function is not bijective because even though it is onto, it is not a 1, 1 function. This function can be called bijective because it is an onto function and a 1, 1 function. Only bijective functions are invertible. Inverse functions will be discussed in a later lesson. Answer this question. Does this represent a 1, 1 function? The answer is no, because 4 is not mapped to anything. So this is not even a valid function. So you can't comment whether it is 1, 1 or onto. If you want to prove whether a function is 1, 1 or not, you can do it the following way. Assume that f of x1 is equal to f of x2. Then show that x1 equals to x2. A function can be represented in this way as well. Here this means that y belongs to the codomain y and x belongs to the capital X, which is the domain. So if we assume that f of x1 equals to f of x2, and then it turns out that x1 is not equal to x2, then it shows that two elements of x are pointing to the same element, which is not the property of a 1, 1 function. And if it turns out that for any general x1, x2 belonging to the domain of the function, f of x1 equals to f of x2 implies that x1 equals to x2, then it shows that the function is 1, 1. Let me demonstrate this with an example. Suppose we have f of x equals to 2x. Then, assuming f of x1 equals to f of x2, that is 2x1 equals to 2x2, we show that x1 is equal to x2. This means f of x equals to 2x is a 1, 1 function. Now, to prove whether a function is onto, you need to show that for every y belonging to y, there exists an element x which belongs to the domain such that f of x equals to y. I will demonstrate this with an example. Let's say f of x equals 2x. The domain is the set of real numbers and the codomain is also the set of real numbers. For every y there exists an element x equal to y by 2 which belongs to the domain of real numbers such that f of x is equal to y. Thus, we have shown that for every y, there exists an element x in the domain such that f of x equals to y. This proves that the function is onto. Okay, that's it for this topic. In the next lesson, we will be talking about composition of functions and inverse functions. Thanks for watching.